All right, so we're starting bivariate data. So bivariate data means we get two pieces of information from the one source. So you know before when we were doing univariate data, so we were displaying, say I recorded all your heights and we were displaying that in a box plot, okay? And we could see the median and all that. When we have bivariate data, what might happen is I'll get two pieces of information from that source. So say I collected the class, I collected your weight and your height. So can you see I'm getting two pieces from every data source. So another thing, like when we do surveys, we might often it's pretty common, do we collect whether you're male or female and then say something else about you. It might be a hand reaction time or something like that, okay? So that's what bivariate means. We're going to be looking at when we look at two pieces of information and we see whether they're related, like when we change one, does it make the other one change? But before we get into that, so we are going to have all these graphs, and from now, and in this unit particularly, they will start to ask you for significant figures. So when you calculate a number, and now it's a little bit different to decimal places. So you can get either in your exam, they may say decimal place like we've been doing, or now, and very common in this one, to use significant figures. So what is significant figures? So when you have a number, so I'll just use this red one down here. So say we've got this number, I'm going to write it up here. So we've got this number written here, like so. If I said round this to one decimal place, just to show you, if I said one decimal place, this would actually be 0.0, yeah? And that's not what it is. It's not 0. There is a number there. Yes, we're talking about small numbers, but that might be what we're looking at. If you were looking at, like, say, we were looking at, you know, the amount in an injection. So we're going to have micro numbers. We'll have small numbers. So it isn't right to say 0, and we need to see those numbers. So this is an example where significant figures will come in. So here's our new rule. So this is how you do significant figures. So your first rule to look at is when you start up, you don't start counting significant figures until you get to your first non-zero number. So for example, I would go through here and it wouldn't be until this 9 that I start counting. So if I was to do one significant figure for this, okay, so it would be, so I start counting as soon as I get, so I've got to the 9. I'd still look at the one after the 9 to see if I'd round it up or not. Because it's a 0, I don't need to. So for this one to be one significant figure, it'll be 0.009, okay? So all non-zero, so this first rule here, all non-zero numbers are significant. So that means, you know, 1, 2, up to 9 are all significant. If you see one of them, you count them. And then the next rule is all zeros in between significant numbers are counted. So what that means, I'll just show you what that means. So say this number again, if I said to go to 3 significant figures for that number, I start counting as soon as I get a non-zero, so that would be the 9, and then you count no matter what. So even though there's a 0 there, I still count that. So 1, 2, 3, and I count it because I've already had a non-zero number. So I count up to 1, 2, 3, and then I look at that, the one after it, because I'm doing 3 significant figures, I look at the fourth one. Now, because it's 5, you have to round up like you normally do. So 9, it'll be 0.0004 for this one, yeah? So that is 3 significant figures. All right, and then it says this last thing. After the decimal point, all zeros to the right of a non-zero digits are significant. So that's just like what we talked about now, yeah? Okay, so let's have, and they've done a few examples. They've done another one. So here, let's have a look at, I'm going to do another example for you just to show you. Now, sometimes we have really, really large numbers as well. So say we're talking about, it can often come into, say, area, like area of a, you know, a suburb or something. And so say we were doing that and it was in meters squared or something, and we had, you know, 493,681, say, meters squared, okay? When we're doing surveys and stuff, and when we're trying to analyze the data, really, I don't really need to know, like, it's not really significant. We don't need to know the all up to the finest little detail. We want to get a rough estimate because we're trying to present this data. So, you know, even if you looked at it, if someone looked at that and then you were replaying the story on how big this thing is, you would probably just go, oh, it was 490,000 square meters. You wouldn't go and ramble off all the rest. So this is the same here. So here, we've got to be careful now. So if we say two significant figures for this one, we have to start counting as soon as we have non-zeros. So here, we got 1, 2, we count, okay. So, and I would look at the third one, and because it's a 3, that 9 doesn't change. Now, if I write 49, is that what the number is? It's not, isn't it? It's 490,000. So when you're this side of the decimal, when you're the left-hand side, once you've got your significant figures, you've sorted out, all the other spots need to become a 0. Does that make sense? Because it wouldn't indicate the number that you're talking about. So can you see that? So if I did 3 significant figures for this one, it would be, now because the third one is higher than a 5, so this one would be 494000. Yeah, that would be 3 significant figures. If I did 1 significant figure, so because that second number's a 9, it'd actually be 500,000. So see how you like sort of rounding to the nearest 100,000, but that is 1 significant figure. So when you're on the left-hand side of the decimal point, when you're in the big numbers, that's what you need to do. All right, so let's go fill in your table here and practice.